Hello everyone. Here I am explaining about deadlock avoidance. Before that, what does it mean deadlock? A deadlock is a situation where a set of processes are blocked because each process is holding a resource and waiting for another resource acquired by some other process. It means, consider an example. When two trains are coming toward each other on the same track and there is only one track, none of the trains can move once they are in front of each other. A similar situation occurs in operating system when there are two or more processes that hold some resources and wait for resources held by other processes. For example, in this diagram, process 1 is holding resource 1 and waiting for resource 2, which is acquired by process 2, and similarly process 2 is also waiting for resource 1 which is acquired by process 1. This situation leads to the deadlock. So there are different methods to handling deadlock. There are deadlock prevention, deadlock avoidance, deadlock detection. So here I am discussing about deadlock avoidance. To avoid deadlock, the banker's algorithm is an efficient algorithm. So what does it mean, banker's algorithm? Banker's algorithm is a resource allocation and deadlock avoidance algorithm. It checks if allocation of any resource will lead to deadlock or not. Determining a safe sequence will assure that system will not go into deadlock. Banker's algorithm is generally used to find if a safe sequence exists or not. Here we will determine the total number of safe sequences and print all safe sequences. The data structures that are used to develop Banker's algorithm are available vector, max matrix, allocation matrix, and need matrix. So we'll see with an example. Here we will be talking about the Banker's algorithm, very easy way to implement, and you can solve this problem in 2 to 3 minutes. That simple it is. Here we begin. The example of a system with 5 processes whose allocation and max are given, and initially the work are available is 3, 3, 2. We need to find out the need of a matrix by subtracting max from allocation. So it will be how to calculate need? Max minus allocation. The max is 753. 7 minus 0, 7. Next 5 minus 1, 4. Next 3 minus 0, 3. So it would be 7, 4, 3. Next for process P1, 3 minus 2, 1. 2 minus 0, 2. 2 minus 0, 2. 1, 2, 2. The next one 6, 0, 0. Next 0, 1, 1. Next 4, 3, 1. So to calculate need matrix, the formula is max minus allocation. Max values are given and allocation values are given. So next, according to the algorithm, we need to compare need of each process with the work. So the work is initially given as 3, 3, 2. So the formula is, let's start our steps. Need less than or equal to work. If the condition is true for each process, we need to calculate the work. That means we need to update the work. The formula is work equal to work plus allocation. So first let me take the process P0. The need of P0 is 743. and the work that is allocated is 332. Now we should check if it is less than or equal to the work. So let's go to the steps. Step 1, process P naught is 7, 4, 3 and the work available is 3, 3, 2. Now compare need and work of the process P naught, which is less than. The need is less than or equals to work. So it's clearly not less than or equal to work. The condition fails. We should check for the next process, that is nothing but P1. So P1, the need of P1 is 1, 2, 2. 1, 2, 2. So we should check which is less than or equal to the work, that is nothing but 3, 3, 2 again. So here 1, 2, 2 is, that means the need is less than or equal to work, the condition true. So if the condition is true, the formula is we have to calculate the work, that is work is equals to work plus allocation. So calculate work is equals to work plus allocation. So work is 3, 3, 2 plus allocation of process P1 is 2, 0, 0. So calculate work 5, 3, 2. The new work is for the process P1 5, 3, 2. So update in the work table, that is 5, 3, 2. Now next move to the next process P2. Calculate P2. So the need of P2 is in the table 600, 600 and the new work is 532, 532. Let us compare whether the need of P2 is less than or equal to work, which is false. So the condition failed. Let us move to the next process. Before going to the next process, we need to keep track of all the sequences. That is nothing but the P1 is successfully executed. So we need to keep track of a safe sequence initialized with P1. So next for P2. So condition failed. Next move to the next process, that is nothing but P3. The need of P3 is 0, 1, 1. 0, 1, 1. So let us check whether it is less than or equals to work, nothing but 5, 3, 2. So the condition true, success. So if the condition is true, we have to calculate the work. So work is equals to 532, that is work plus allocation. Allocation of P3 is 211. So 211 is equals to 743. So the new work calculated is 743. Next move to the next process, nothing but P4. For P4 the need is 431 and let us check whether it is less than or equals to work. The new work is 743. So the condition true. So as we have calculated P3 and P4, which will go under safe sequence P3 and P4. Next, the P4 condition true, we have to calculate the work, new work. Update in the table, that is 743 plus allocation of process P4. Allocation of process P4 is 002. 002, that is equals to 745. So the new work should be updated in the table 745. Next, Let us move to the next process. So here we have finished up to the P4, but some conditions failed for some of the process, nothing but see here P0 and P2. So we have to recalculate again. P0 need is 7 4 3. Now let us check with the new work, that is nothing but 7 4 5. Yes, now the condition is true. Condition true, so we have to recalculate the work, that is nothing but 7 4 5, and the allocation of P0 is 0 1 0, that is equals to 7 5 5. So the new work is 7 5 5. Next, the P0 will enter into the safe sequence. Next, last process nothing but P2. The need of P2 is 6 0 0. Let us check whether it is less than or equal to 7 4 5 work. So now the condition true, 600 600 is less than or equal to 745. So the new work is equals to 755, updated work 755 plus allocation 302 is equals to 10 5 7. So P2 also entered into safe sequence. So the safe sequence to avoid deadlock and to process all those 5 processes is first P1, P3, P4, P0 and P2. So the process is, I'll repeat once again. In the problem they have given 5 processes along with allocation max values, and the initial value of available or work is 332. So we need to calculate the need matrix. So need matrix calculation by the formula max minus allocation. So subtracting allocation from max, we'll get these values. After that we need to compare need of the matrix of each process with the work of initially that has been given. So for each process we have calculated the work and updated in the table. Later we can get the safe sequences of all those processes. Thank you.